Hello everyone, thanks for having me. My name is Keeyon Ebrahimi. Right now I'm a master's student at NYU studying computer science, and I'm going to be talking to you guys today about Scheme. It's a little intro to Scheme. And yeah. So, here is my slides. Intro to Scheme, the greatest language that ever was. I am very in love with Scheme. I think you guys will also fall in love with it too. It's really cool. So what is Scheme? Scheme is a functional programming language. I'm sure you guys have heard a lot about those. Scheme's a really cool one. There's two dialects of Lisp, and Scheme is one of those. There's CL, which is Common Lisp, and then there's Scheme. So Lisp is like one of the very first programming languages, like higher programming language. Like it was the second one right after Fortran. So it's really old and super hipster, really cool. And so Scheme is a dialect of that. And it was actually invented to help people like learn how to use functional programming. It's very bare bone. It's like made very simple. The syntax is like pretty easy to understand the flow of things. And I'll go over more reasons why it's so nice to learn functional programming with. But yeah, it was made to learn like how to code functionally. And so this talk I'm going to kind of go over like a lot of the functional programming basics because that's what Scheme was made for. So I feel like that's the best way to get into Scheme. So in Scheme, there's a bunch of expressions, and all expressions are either an atom or a list, so a single element or multiple elements. The way you evaluate these lists is by applying this very first element of that list to the rest of the arguments. The way we iterate as well in Scheme is we don't actually use for loops, we use recursion. See that in, that's what functional programming, that's the power of functional programming. In all these functional programming languages, you're going to see a lot of recursion. And also in Scheme, all these different expressions will be held in parentheses, and we'll see that here. Cool. So like I said, Scheme everything is an atom or it's a list. Here's how you define and create lists. So as you can see, we start the very first expression with the parentheses, and we say parentheses list 1, 2, 3, 4. Simple as can be, and that returns a list 1, 2, 3, 4. We can also do the same thing with the apostrophe. 1, 2, 3, 4 gives another list, or quote. Cool. Another cool thing about Scheme is lists can be nested. So as you can see here, we have a list that has, integer 1, 2, another list, and then 5, 6. So some languages, if you have a list, every single element in that list has to be the same type. Like, for example, if you have a list of integers, everything has to be a number. You can't have a list that has single numbers and then also a list inside there. But in Scheme, don't worry about that. You can have a list with single elements and list has a different element, and so yeah, it's super basic and easy that way. Whoa, something's going on outside. Cool, so here's how we define variables. So once again, we have these parentheses, and that starts the expression, and we say, we have the keyword define. The next thing it takes is the name of the variable and then what it should store. So here I put, parentheses, define x5. That'll store, 5 into x. Then when I run x, it returns 5. Simple as can be. Now with functions, pretty similar as well. We have, parentheses define, and then we give, right here, this next expression is going to be the name of your function and then all of your arguments after that. So I could have, one thing here, 10 things here, and so forth. So here's the name, f. We're taking in x and y. And then here's what we do with that. The next expression here is we take, we do an addition. And so as you can see, everything, like all our expressions, we're going to do parentheses and then the name of whatever expression we should run. And so you're used to seeing like x plus y, but in Scheme you do plus, which is, we're doing the addition operator, and then all its arguments come after. So you're always going to see that. You see the name of the expression and then all of its arguments come afterwards. So here we do, plus x, y. And then here's what happens when we run that. We start our expression, we give the name, which we define up here, and then our next arguments. X is going to be 5, y3 gives us 8. Cool. Yeah, here's how we do conditionals. And I'm going to go over like all these like basic things and kind of show a couple cooler, applications of this later. But here's how we do conditionals. So first you can do either an if, or if there's more expressions, conditional expression. So the way if works is So the very first expression is going to be something that evaluates to a Boolean. So here we say, okay, if equals x3, so this will give us a true or false. If it's true, we're going to run the command that happens right after, which would be just a string yes, just print that out. And if it's false, it'll run the expression after that first one, so run the second next one, which would be no. So here we define x as 5. We then say, okay, if this, if equals x and 3, which it doesn't, so it'll go to the second expression and return no. So that's for basic ones, you can do that. Conditions with like multiple branches that you can go down, you do it this way. So you have the condition expression, and then you give it multiple expressions after that. So here's the first expression, then second, then third. Cool. The first expression, kind of like the if, what happens is, for each of these expressions, you will start with something that will give you a Boolean, so true or false, just like the previous example. So equals x3, we'll return s is 3. If that doesn't work, we'll go to the next line. So if it works, it'll print out that x is 3, and we'll end this entire expression and kind of come out. But if that doesn't, if this true is not satisfied, we'll go to the next one, which is this. Cool. So we look at the expression and say, all right, the first element of this expression has to give us a true or false. And so it says, okay, the first element is now this. And so as you can see in Scheme, there's a lot of parentheses, and at first it seems a little jarring, a little kind of busy. But the cool thing about it is you can really very easily tell the order of things that are happening. You're never wondering when each thing is happening. You can easily tell what's first, what's next, and so on and so forth. So cool. So this expression will give us a true or false. We have equals x, and then the second thing that x has to equal is this expression, which is 6 minus 1. So if x equals 5. And then if that's the case, we'll get out of this Boolean and we'll return whatever comes next, which is 5. And what's cool about this example too is, as you can see, here we say we compare the x's to a number. Here we can also do the exact same thing, but instead we are comparing that x to a whole other function. It's another function call to a subtraction. So as you can see, things get really nested with like functions and functions and calls, and that's kind of how functional goes down. So cool. So this happens, we return 5 if this is true. In our case, we defined x as 5, and so it will actually return this. And after all your conditionals though, you can always have an else, and then if none of the previous ones happen, this will always return true, and then it'll run that. So in our example, we get 5. That is conditionals in Scheme. So as I said earlier, Scheme is, deals with either atoms or lists. Here are different things we can do with lists. Here are little operations. So the first is car. So let's say you have an entire list, and as I said earlier in this little workshop, the way we kind of deal with a list of data is we will take the very first element of that list and kind of use that and recurse through the entire list, and we'll use these operations. So first we have car. And car, if you've done functional before, I'm sure you've heard of like head or things like that. Car is the same thing. It just returns the very first element of your list. So here we start this car expression and we give it a list 3, 4, 5, 6, and this returns 3. Simple as can be. And then cdr is pretty much the opposite of car, where car is the head, cdr is the tail, meaning it is everything excluding the very first element. So it turns a list of all your elements that does not include the head or the very first element. So as you can see, we give a cdr right here, we give it the list 1, 2, 3, 4, and it returns a list excluding that first car element. So then it gives us 2, 3, 4. Returns a list. Cool. Now here's a cool, functional programming little code snippet where we're using car and cdr to kind of see the power and the beauty of functional programming. So we have now have a little function that will access the nth element of a list. So if you give it, 5 and then an entire list of a bunch of elements, it'll return whatever the 5th element is in that list. So how do we do that? So as you can see, we have this define, we have this function, and it's going to be called nth, and then everything else after that is going to be the arguments. So n and l. And then, to skip a little bit ahead, we have more calls to nth. This is going to be a recursive call, as we have said earlier. Functional programming, it's all about recursive calls. So this is going to be recursive, and in all recursive calls, you want to have a base case where you return out, and so you don't infinitely go. And so for our base case, we're going to make it so if they want the first element of the list, we'll just return the car, because we know car already does that. Car just gives the first element of the list, and so if n is 1, return that first element. Cool. And for our next expression, because our base case is 1, we're going to try to work our data to get our initial argument down to 1. So once we hit that 1, we'll hit our base case and we'll finish. So we're going to try to work down. And so if n equals 1 is our base case, we're going to want to make n be smaller and smaller and smaller until we hit that base case. So we'll do the base case, and then if we're not there yet, we'll run this. Else is always true, and then we'll do, cool, we'll have a little recursive call into nth, where the first thing we give, the first argument for nth will be this expression, which is cool, a little function that we're gonna put inside of the call, which is pretty sweet. But yeah, this expression is gonna take our n and minus it by 1. So if our initial n is 5, we're gonna minus by 1 here, and recursively call and give it 4. Cool. And then we're gonna, every time we do that, we want this list to be smaller and smaller and smaller, because we're dealing with the very first element and the rest of the elements. And so so I should rewind a little bit. So in our base case, actually, when we do hit that 1, we'll return the very first element of our list. And so we're going to want to change what the first element of our list will be. As we know, cdr is going to constantly give us the entire list, but it'll take off the very top element. And so if we are taking off the very first element 5 times, then our next element will be the 6th element, right? And so we want to run this until our n is, so n is going to be minus every single time by 1, and we're going to give it a list that's smaller and smaller and smaller, taking off the first element, first element, first element. And so when we give it here, so we give it 4, right? We say nth, we're going to give it the number 4 and give it this list. And so if we look at the code here, what's going to happen is we're going to say, okay, cool. Does n equal 1 yet? No, it equals 4. Well, then we're going to come in here and see, okay, we're going to recursively call. N is now going to be, 3, because we're going to minus by 1. And the list that we're going to be giving it is now this list. So we'll give it this list, n is 3. We'll do the same thing one more time. Now n is 2 with this list. Okay, cool. Then we'll run it again, and then n will be 1 with this list. Now that n is 1, we're going to say, well, that's our base case, n is 1. Return the color of this list, which is the very first element, which is 8. Awesome. So here's how we find the nth element of a list using functional programming. Yeah, awesome. So then another list operation we can do. So we have car, we have cdr, and the last one is const. So car and cdr kind of reads from the list, and you kind of grab an element from the list. Const is how you add elements back onto a list. And so what's going to happen is you're going to give it a single element and a list after that. And const will return an entire list where the first element is kind of added onto the list that you're giving it. So here we say, cool, const, so this expression starts with const. The first argument is our single element, 3. And then our second argument that we're giving it is going to be a list, 4, 5, 6. Const takes the first element, adds it to the list, and we return 3, 4, 5, 6. Sweet. Now we're going to go to a little more complicated, some more cool code you can do. So Scheme has an append where you can give it 2 lists now, and it'll make 1 list. which is pretty close to const, but instead of adding a single element to a list, you're adding two lists together. So you can use the scheme append, but just to kind of show you how functional programming works and the power of car encoder and const, we're gonna show you our own example of append. Sweet. So here is the define call. We're gonna start a new function. Then we have it called append app, and then L1, L2. So we're gonna have these contain lists. So like in the previous example, we're given the nth item. What we're doing is we're taking off one element of a list, and then kind of recursively taking off another first element, another element, another element, another element, one by one. And so in our append, what we're gonna do is we're gonna have two lists, and we're gonna one by one place things that were in list one and put them into list two. So by the end of this, we're gonna want list two to have all of our elements, and list one will be empty. Cool. Now knowing that, we'll check out our base case. So our base case is this. So we start a condition, so a bunch of ifs, and the first one is right here, and this null question mark tells you if this list is empty or not. And so we'll say, okay, we'll run this little expression, and then the argument is the list. So if this evaluates to true, so as you remember the conditions, the first thing has to be a Boolean. So if this evaluates to true, we will return the next element, which would be list two. So that's our base case. So if the first list is done, then we'll just return the second list. Now we will actually go into what happens when we're not done yet. So else, so if we're not adding the base case, we will first look at the innermost parentheses, which is right here. So we're going to take the first element of our unfinished list, and with this, we're going to run const. So as you remember, const will take a single element and we'll add it onto another list. And so we're doing const. Car will return a single element, and so this will give us, one element, and then we will append that to the remainder of our first list, and then our list two. So I can kind of go over that with this example here. We'll give it 1, 2, 3, and 4, 5, 6. Base case won't hit first. Then what's going to happen is we're going to take the very first element of this list, 1, which we know from here. We'll take this 1, and we're going to add it onto this expression, which is going to be a recursive call of another append call with this being our first list and this being our second list. And so little by little, this is going to empty out. And once that's empty, that'll return, it'll put the 3 there, 2 there, 1 there, and you will get your appended list. Awesome. We have so map is actually really powerful as well in functional programming. You'll see it a lot, where what a map does is it applies a function to every element of a list. And so now instead of just like taking the list out and adding, or taking an element out of a list and putting it in a new list, you can now do things to those elements in your list. You can, so here's an example where, so map is going to apply a function to every single element of a list. So we're going to just make a simple function. So here we define the function name is f. It's going to have one argument, which is x, and then it's going to run this operation. It's going to add this argument as x, and it'll add it by 3. Cool. So you see we do map, and what map will do is it'll take a function, it'll take a function as its first parameter and a list as its second parameter. And so the function it's taking is this, so it'll add, so here's a list, and it'll take the very first element of this list, 2, and it'll put that into f. So it'll get, okay, 2 plus, 2 plus 3 is 5, then I'll do next one 4, and so on and so forth. It'll give us a list that'll add 3 to every single element. Cool. And now we can do, oopsies. Here's lambda. Now lambda is a way you can, all lambda is, you hear it a lot, but it's just kind of an in-place function where instead of like defining, a function outside, you can just find it in one line, and it's really cool. So in this map example, we defined this function and we ran it here. But instead of just putting the name of a function here, we can just define it in that same line with lambda. And so map, the first thing it takes is a function, which will be right here. Cool, so let's go over what lambda does. Lambda will take, the first expression after lambda will be the arguments, and everything after that will be what it does with those arguments, like what the expression will evaluate to. So it'll say, okay, here's a function that takes an x, it takes an x right here, and then it'll run x times 3. Cool, so here's the function, right there, inline function, lambda. And then our map takes that function, and then it takes a list, and as you can see, this will return that same list where we multiply by 3 on each of those elements. Sweet. Also, here's let. And what let does is it lets us actually use local variables. So let's say there's you have a really complicated function that's going to be using the same data multiple times. You don't want to constantly write out a 10 nested, expression within there. You can just use let, so you can define it once and then keep on using that variable within that function. So we have this, here's an example of that. So we have, define, so we create this function foo, and then, as you remember, after the name comes the variables, and here are the variables for this function. It's going to be this expression. So instead of just being x and y as an individual argument, we're going to define multiple things right here. Anyway, okay, never mind, I didn't mess that up. No, so this function actually has no arguments. It's just called foo, and then within there we're going to define our own little local variables. So it starts with let. Here's going to be everything within the let. The first one will be here. We'll say, okay, x is 3, and then here we'll say y equals, 7 plus 4, so it'll be 11, and then let's see where this ends. So let should go all the way to here. Awesome, perfect. And then the function will just run this, which is x times y, x is 3, y is 11, so it gives us 33. So that's let, local variables. There's also a let star and a let rec, and all let star does is, let's say you wanted your y, instead of being 7 plus 4, you wanted 7 plus x. If you did a let, it would crash, it would not run. And so instead, you put a let star here, and knows, okay, there's recursion going on here. Evaluate this completely before you start setting what y is. So then there's let rec. So as you saw, inputs can also be not just little variables in data, but it can be functions too. So if you're gonna have recursive functions, instead of this little variable here, if you want a function, the lambda function of some sort, you would use let rec here instead. Let rec, and then you could run functions there, so on and so forth. So these are the very basics of functional programming. And yeah, so Scheme was made to help people learn how to functionally program. So hopefully this has kind of helped understand how functional program works. Thanks for having me. I also have something cool I can show you guys. I don't know if I have enough time, but yeah, cool. So here is a little Scheme. Oh, it's kind of small. So here's my Scheme REPL, right? And then I can let's see here. I can do things like define x and cool, little Scheme REPL, great. There's this thing called Dr. Racket, which I really suggest people to look into if they enjoy Scheme. So Dr. Racket is this cool little IDE, which it's like a little debugger for Scheme, which is pretty cool because it's kind of hard to have debugging tools for functional programming and functional code. And so another reason why Scheme is a great tool to learn how to code functionally is it has this debugger and it has this has this cool IDE that helps you out. So for example, to show you how this works, let's say we'll run a little Fibonacci. I'll show you guys Fibonacci real quick and kind of just show you how the debugger works. So I think, how much time do I have? I can go
like a minute or two.
Okay, so I probably shouldn't go over all this, but I'll just define the n, and we'll just do add 3, add 2, it takes in x and y, and then we'll do plus x, y. Awesome. And then we'll do add. This is a very basic function, but 4, 9. Awesome. So as you can see in the top right up here, we have a run, which is run it, and it gave us 13 as we see. But let's say for some reason something was not going as we thought. We hit this little debug button up here, and then once you're in debug mode, you can kind of hover over parentheses, and then as you can see when I go over this one, it goes red. I can right click at that point, and I can pause. And so when I run it, it'll actually hit that breakpoint, and it'll say, okay, now here's the stack. So it shows right there, we're in at 2, and then it also should show the variables as well. So first we went into add 2, then we went into addition, and now that we're in addition, which is right here, we have 2 variables, x and y, right here. So add 2, then plus with these variables. And so that can be really nice if you're functional programming and you're like, not sure what's happening. Here's a cool little debugger that'll help you out, and it's called Dr. Racket. And yeah, thanks so much for having me.